Welcome to this explainer. We usually associate a great glass of wine with romance, terroir, maybe incredible craftsmanship, right? But today, we're diving into the completely fascinating, hidden chemical warfare happening inside every single bottle. Behind the scenes, winemakers are actually fighting a constant microscopic battle to protect their vintage from turning into an absolute disaster.
So you see a beautiful, elegant pour of red wine. It looks perfect. But lurking right there within that vibrant ruby liquid are microscopic enemies, literally just waiting for the perfect condition to strike. Specifically, we're talking about lactic acid bacteria. If they're left unchecked, these tiny organisms will just feast on the wine's compounds, completely destroying both its physical and chemical properties. It's wild.
Let's take a look at our pathology report for today. First, we'll identify the hidden enemies. Then, we'll diagnose their specific attacks: lactic pitting, ropiness, mannitol and aromas, and bitter ends. Finally, we'll wrap up with the cures.
All right, let's jump straight into Section 1, the hidden enemies in wine.
Now, these microbial culprits actually originate right out there on the grapes in the vineyard, but they mostly lay dormant during that initial alcoholic fermentation. We're talking about lactic acid bacteria, or LAB for short. Now, to be fair, under controlled conditions, they're actually helpful. They soften up harsh acids. But uncontrolled, it is pure chaos. You've got your homofermentative bacteria, which only produce lactic acid, and then you have the overachievers, the heterofermentative bacteria. These guys pump out a whole cocktail of lactic acid, acetic acid, ethanol, and glycerin.
Moving on to Section 2. Let's look at our first specific case file, lactic pitting, a sour turn.
So lactic pitting is actually one of the most common alterations you'll see, and it's triggered by a massive spike in both lactic and acetic acids. But what's really fascinating here is how we can diagnose it like a doctor, using just our senses. Visually, the wine develops this eerie, greasy, iridescent veil on top. When you smell it, that elegant fruit aroma is totally gone, replaced by what's known as a sick wine odor. Think like rancid butter or funky dairy notes. And the taste? It's a highly unpleasant, totally unstructured, sweet and sour vinegar sensation.
Okay, on to Section 3, ropiness. This is when wine turns oily. As you know, normal wine splashes and moves really easily in the glass. But in a ropey wine, the bacteria actually take leftover sugars and synthesize them into these massive complex sugar chains called hexacellular polysaccharides. Basically, these chains link the bacteria together, turning the wine incredibly viscous. It literally pours in a thick, continuous, oily stream. And surprisingly, this is shockingly common in young white wines that just failed to finish their fermentation.
So visually, a ropey wine is cloudy and oily. But the smell? That is where things get truly bizarre. Because at first, it doesn't really smell bad at all. The liquid actually becomes so incredibly dense that the high surface tension traps its own aromas right inside. You literally have to violently shake the glass to break those microscopic structures just to get a whiff of it. But trust me, once you taste that unctuous, rancid texture, you'll realize it is completely undrinkable.
That brings us to Section 4, mannitol and bizarre aromas.
You might be looking at what seems like a perfect pour, but in sweet wines, or maybe reds that just have some leftover fructose, those heterofermentative bacteria we talked about can strike again. They eagerly consume that residual fructose, degrading it, and they actually leave behind literal star-shaped or flower-shaped crystals of a compound called mannitol. It's wild to think about these little geometric shapes forming right in your glass.
This whole process creates what's known as the monotata taste. Visually, the wine gets cloudy with an oily top layer, and it gives off this musty, lactic odor. But the taste is the real giveaway here. See, mannitol is a polyalcohol, so it tastes incredibly sweet. However, those exact same bacteria are simultaneously producing sour acetic acid, so what you get is this agonizing clash in your mouth, sweet, overripe fruit that is just heavily masked by sharp, sour vinegar.
And then, oh wow, there's the geranium smell. Now, winemakers will sometimes add sorbic acid to wine as a preservative, but these bacteria, they just eat it right up. First, they hydrogenate the sorbic acid into sorbinol. Then, that sorbinol reacts directly with the ethanol to form this incredibly complex chemical, 2-ethoxy-3,5-hexadiene. The end result of all that chemistry? A completely pungent, overwhelming smell that reminds you of crushed geranium leaves or cheap air fresheners, or honestly, even bug spray.
Let's open our final pathology report in Section 5, bitter ends, focusing on glycerol degradation.
Now we're getting into the really severe diseases, the ones that destroy the absolute core structure of a wine. First up is what's called the turn, or the rebound. You see, tartaric acid is basically the backbone of a wine structure. When these desperate bacteria run out of other acids like malic or citric, they go straight for the tartaric acid, breaking it down into oxaloacetate and pyruvic acid. And without that tartaric acid, the wine literally falls apart. Red wines turn this muddy chocolate brown color, and whites turn alarmingly dark.
And then we have glycerol degradation. Lactic acid bacteria essentially hijack glycerol, which is what normally gives wine that really nice smooth mouthfeel, and they transform it into a compound called acrolein. Now, acrolein all by itself actually isn't bitter, but when it reacts with the natural phenols floating around in red wine, it creates a deeply unpleasant, aggressively bitter taste. The wine ends up dropping its color as sediment, starts smelling like spoiled garbage, and leaves a terribly bitter finish right on your palate.
So, how do we fix this? That brings us to Section 6, Saving the Vintage, the Cures.
With all of these microscopic monsters out there, winemakers essentially have to act as both doctors and scientists to save their patients. Their daily preventative toolkit involves meticulously keeping fermentation temperatures below 20 degrees Celsius, carefully managing sulfur dioxide to hold bacteria at bay, and making absolutely sure the yeast consumes every last drop of sugar so there's nothing left for the bacteria to eat. But if the bacteria do manage to take over, winemakers have to deploy some pretty drastic curative methods. We're talking expensive pasteurization at 60 degrees Celsius, using bentonite clay clarification to physically drag the dead bacteria out of the liquid, or vigorously shaking vats to literally shatter those oily bacterial chains we saw in ropey wine.
It is a constant, delicate, microscopic balancing act. Honestly, every single beautiful glass of wine you enjoy is a hard-fought victory over these bacteria. So I'll leave you with this final thought. Next time you uncork a bottle and take that very first sip, will you taste the fruit of the vine or the remnants of a microscopic battleground? Thanks so much for joining me for this explainer, and keep exploring the fascinating science hidden all around us.